Hello everyone. In this video, we will understand uh, the limits of correlation coefficient. Means how to prove that correlation coefficient, which is denoted by small r, is lying between -1 and +1. So we will see the proof in this particular video. So first, let us consider the following sum of squares. Sum of squares. So summation inside a box bracket, we are going to write x minus x bar divided by sigma x plus or minus y minus y bar divided by sigma y the whole square, where any sum of square has to be cannot be negative, which means this has to be greater than or equal to 0. That is clear. So here we will say where this x bar is arithmetic mean of variable x, y bar is arithmetic mean of variable y, sigma x is standard deviation of variable x, sigma y is standard deviation of variable y. Now, we know in algebra, we have a plus b, the whole square is a square plus b square plus 2ab. Similarly, a minus b, the whole square is a square plus b square minus 2ab. So together we can very well write this as, if it is plus or minus b, the square, then I can say it is a square plus b square plus or minus 2ab. So why we are using this algebraic identity is that we are going to use this in the above inequality. Right. Let us proceed. Now let me expand the above inequality. So I can write summation. First one, x minus x bar by sigma x, the whole square, plus y minus y bar by sigma y, the whole square, then plus or minus 2 times x minus x bar by sigma x times y minus y bar by sigma y. Inside the brackets, this should be greater than or equal to 0. Right. Now let us take, here we may notice here x comma y are variables and x bar, y bar, sigma x, sigma y are constants. So when I take the summation inside, first let me rewrite this again. We will take the square in the numerator and denominator separately. So this is x minus x bar, the square, divided by sigma x, the square, plus y minus y bar, the square, divided by sigma y, the square, plus or minus 2 divided by sigma x, sigma y times x minus x bar, y minus y bar. Whole thing inside the brackets should be greater than or equal to 0. Nothing we did, we just took this square in numerator and denominator separately and wrote it. Now we will take the summation inside the brackets. We will have summation x minus x bar, the square. We may note this, since sigma x is a constant, sigma x square is also a constant, that won't come under your summation. So you can write like this. Similarly, the next term, summation y minus y bar, the square, divided by sigma y, the square, plus 2 divided by sigma x, sigma y, summation x minus x bar into y minus y bar. This whole thing should be greater than or equal to 0. Here I should write plus or minus greater than or equal to 0. Now, divide both sides by, then n is number of observations, number of pairs of observation, pairs of observations of x and y. That is what is our n. So when I do that, I will have summation x minus x bar, the square, divided by our n. Then we have 1 divided by sigma x, the square, plus summation y minus y bar, the square. You are dividing by n. 1 divided by sigma y, the square, plus or minus 2 divided by sigma x, sigma y. Then this summation x minus x bar into y minus y bar, this divided by n, greater than or equal to 0 by n will be 0 only. So I can simply write 0. Now, let me proceed to the next page. This term is nothing but variance of x. This term is nothing but variance of y. This term is nothing but covariance of x and y. So I will say, since sigma x square is nothing but summation x minus x bar, the square, by n, comma, sigma y square is summation y minus y bar, the square, divided by n, comma, covariance of x comma y is summation x minus x bar times y minus y bar divided by n. We have, so this inequality, we will write this one, we will write it as sigma x square multiplied by 1 by sigma x square, then plus sigma y square multiplied by 1 by sigma y square, then plus or minus 2 divided by sigma x, sigma y. This term is nothing but covariance. This should be greater than or equal to 0. Now, this implies that sigma x square into 1 by sigma x square becomes 1. This sigma y square into 1 by sigma y square becomes 1, plus or minus 2 times. Let us consider this term, that is let me put this. This is actually 1 because nothing is there in the denominator. So that term is R, because the definition of correlation coefficient is, let me write, since R is equal to covariance between variables x and y divided by standard deviation of x, standard deviation of y. So because of that, we are replacing that term, that is covariance of x comma y divided by standard deviation of y as r. This is greater than or equal to 0. That means 2 plus or minus 2r greater than or equal to 0. Divide both sides by 2. We will have 2, 1. It will become 1 because you are already planning to divide it by 2. So if I divide it, becomes 1 plus or minus 1r. We can simply write it as r greater than or equal to 0. So one possible is, that is 1 plus r greater than or equal to 0, or 1 minus r greater than or equal to 0. So this means that r is greater than or equal to, bringing that 1 to the right hand side, it becomes -1 plus 0. Here it is taking that -r to the right hand side, it becomes 0 plus r. So this becomes r greater than or equal to -1. This becomes 1 greater than or equal to r. Now, together we can write this as, that is, I'll put r in the center. It should be less than or equal to, I mean, this implies that -1 is less than or equal to r. So I can write -1 less than or equal to r, and this I can rewrite it as r less than or equal to 1. So together it can be written like this. Hence the proof. Hence the proof.